Okay, this is the homework help video for, sorry, I should have gotten this organized a little bit. Okay, all right, let's try that again. Okay, so this is the homework help video for Honors Math 3, Unit 2, Assignment 4. So this is the second half. So there's another video that does kind of the first half. So this is just to do the second half. So I'm going to start with question number 27. So for question number 27, we want to solve the quadratic equations for x. So the first thing I do is I want to factor. So it's already equal to 0. So for factoring, I see that both of these have an x minus 1 common. So that means I can factor that out. So when I factor out the x minus 1 from both of them, I'm left with x plus 9. Okay, so again, this up here has an x minus 1 in it, and so does this. So that is my common factor, so that's what goes first. And then when I divide x minus 1 out of here, I'm left with an x. When I divide x minus 1 out of here, I'm left with a plus 9. So then once I have it factored, I want to set each factor equal to 0. So that means I'm using the zero product property. So my first factor, x minus 1 equal to 0. And then I also want to do x plus 9 equal to 0. And then from there, I would solve. So I'm going to add 1 to both sides to isolate the x. And so 1 minus 1 is 0. So I would have x equals 1. And then for this one over here, I would subtract 9 from both sides. And then when I do that, I would have x equals negative 9. So then my solutions are negative 9 and 1. Okay, so there's number 27. And then let's take a look at 45. So we're going to jump to 45 here. So for question number 45, again, I'm solving for x still. So this one is one of the composite function problems. So right here, I have f of x that I want to substitute in for g of x. So here is my f of x, and I want to substitute that into g of x. So all of the rest of the equation is going to stay the same. So I still have a 20 here, and then plus 3. And then this portion right here, so then x plus 7 will become squared, right? So the x goes out and replaces with x plus 7. And then equals negative 34. So then that's the equation I'm solving for. So I have the 20 plus 3, and then my substitution, so x plus 7 squared, and then equals negative 34. So then to solve this equation, when I look at this, I want to isolate the squared term, and so I'm going to solve by square rooting. So I could distribute combined like terms and do it differently, but because I only have one x that I'm trying to isolate, then it would be easier just to solve by square rooting, or more direct, I should say. So to get this by itself, the 20 and the 3 need to go to the other side. So in order to do that, I want to start with adding and the subtracting. So I'm going to subtract the 20 first. So 20 minus 20 is 0. And then combine those values, so negative 54. And then now I want to get rid of the 3, so I'm going to divide both sides by 3 since it's multiplying. So 3 divided by 3 is 1, so then I'm left with x plus 7 squared, and then that's negative 18. And then to get rid of the squared, I want to square root both sides. So this will be absolute value. And then that negative can come out, so that would be an imaginary number. And then I can simplify the 18 as well. So I'm going to do that kind of in 2 steps at one. So then I have a positive and a negative version, right, whenever I have absolute value. So this would be x plus 7, and then equals. So 18 is the same as root 9 times root 2. So the square root of 9 is 3. So that would be 3i root 2. and then the negative version. And so this is really the same, right? So I can go ahead and combine those, right? So this was like a shortcut way for us to do that. So because these are both the same term, but one's positive, one negative, another way to look at that, right, was x plus 7, and then plus or minus 3i root 2. And so it is okay for us to go straight to here. Like that is an okay thing to do. We can still keep splitting, like there's nothing wrong with that either, because sometimes that's better. But I can also just go straight into that format as well. And then my last step is to subtract the 7. And then the order in which I put my final answer, it's important, and mostly that's because of like what we call standard notation or a standard formatting, is we would want the radical last. And that's just because sometimes it gets confusing on people extending the radicals. So that means I want my negative 7 first, and then my imaginary piece, which is 3i and then root 2. And then that would be my answer for 45. Okay, and then let's take a look at that one on the back here. Okay, so we're going to go to question number 49. So for question number 49, let me get some graph paper. So what I want to do for 49 is I want to graph this. So in order to graph it, the first thing I want to do is find my zeros. So that means I want to go ahead and factor this. So I'm looking for factors of x squared, which are x and x, and then factors of negative 8, that would also give me negative 2. So I'm just going to do my factors above it here, so a little backwards. So factors for 8 are 1 and 8, or 2 and 4. And I know one of the numbers needs to be negative because I have a negative middle term here, and then negative 8. And so I know the bigger number needs to be negative, otherwise I won't get a negative 2. And so if I were to take a look at negative 8 and 1 and combined that with the x, I would not get negative 2. So that means I would be using 2 and negative 4. So to check it, I would distribute. So that would give me x times x is x squared, and then 2x and negative 4x combined to give me the negative 2x, and 2 times negative 4 is negative 8. So again, I'm looking for 0, so I'm going to equal this to 0. So I'm going to set each factor to 0. And that's not a 3. And then my other factor equal to 0, so add the 4. Okay, so let me get my graph paper here. Zoom out just a little bit. Okay. So I have x equals negative 2, and then positive 4. So then I want to find the middle, so I'm looking for my middle here. So my middle would be here at 1, so that would be 3 units to the right and 3 units to the left. Yeah? So then once I do that, I know that my center is at x equals 1. And so then I want to evaluate the equation that I had at x equals 1. So I'm just going to go up here into my factored form, and I'm going to evaluate that at x equals 1. So I have f of x equals the absolute value, so I'm looking up here, of x plus 2, but x is 1, and then of x minus 4, so 1 minus 4. So that would give me 3 times negative 3, which is negative 9, and that absolute value is positive 9. So when x was 1, my y value was 9. So then I'm just going to go up to 9. And then if I want to be a little bit more precise on the center, I know that my stretch here is just 1, right, because it's 1x squared. So normally we would go up 1 over 1, but because it's a reflected, right, reflected, then it's going to be down 1, left 1, right 1. And then I'm just going to go ahead and try to connect these dots. I'm at a weird angle, so that's a little tricky. Okay, so there is the middle part of the parabola that got reflected, right? So normally, just a reminder, our parabolas do something like that, yeah? When we have an x squared graph. So that's normally what a parabola would look like, but when I take its absolute value, anything that is down here would reflect the across the x-axis. So this piece would reflect up here. So that's what I just did, right? I did the part that's down here and reflected it up. And so then now I have these two ends that don't move, and then I want to be pretty accurate, right? I don't need to be perfection, but I want to be pretty accurate. So a couple ways I could do that to make sure that I am accurate is I would just evaluate the same equation I just did, you know, at you know, 1 point to the left and 1 point to the right of my x-intercepts. So I'm going to just do that over here. So I'm going to just do like a little t-table here. Okay. And so this x was at -2, so I would evaluate at -3. And again, I'm going to do it into the product one because that makes it a little bit easier to do the mental math. For me anyways. So that would be -3 plus 2, which is -1. And then -3 minus 4, which is -7. So that would be +7, and so I would be at +7. And so that would be this half of the graph. And then because of symmetry, this would be at the same height. And there we go. Okay, and that's it for this video.